All right, students. So one more good question from the topic of rigid bodies and rotational motion. Very useful practice question. And let's read it. So you're given two bodies. Their angular momentum is equal. Okay. So they are equal in angular momentum. The moment of inertia of A is bigger than B. We have to find a relationship between kinetic energy of A and the kinetic energy of B, which means are they equal, which is greater, which is less, etc., etc. Right? So let's think through this. So how do we use this information? So we know LA is equal to, so which means MA. So the angular momentums are equal. But let's see how can we use the angular momentum to find kinetic energy. If a body is in having an angular momentum, it doesn't say that the body has any linear velocity. Seemingly, what it has is a moment of inertia and an angular momentum. So I will treat this as a situation of a rigid body moving with an angular velocity. So let's say the kinetic energy of a body. So one is this expression, right? But since it is not mentioned, it's a point mass. The second approach could be you could take I omega as your angular momentum, right? So I will start with this, and I will try to use I omega is equal to L as one of my alternate approaches. So half I omega A squared. This is the kinetic energy of the A body. Let's write the kinetic energy of the second body. So we know second body of I omega B squared. So we know these are the expressions of kinetic energy. The body is having an angular velocity and moment of inertia. Now we know this. The angular momentum is equal, which means we know that IA omega A is equal to IB omega B. We know these two are equal, right? Now, how do we use this expression? Okay, and this expression, right? So, to find a relationship between these two, right? If I divide the two expressions, right? So, if I divide the two expressions, I get kinetic energy of A divided by kinetic energy of B to be equal to IA omega A squared divided by IB omega B squared. Now we know IA is greater than IB, and now this fraction is greater than 1. What is that we need to worry about is the omega A divided by omega B. Let me use this for instance, right? So omega A divided by omega B is equal to IB divided by IA. If you do square of both the sides, okay, if you do square of both the sides is equal to IA, IB, and squaring. So I'm using this expression. Angular momentums are equal. I used I omega. Using that, I am getting IB squared divided by IA squared. Right? So this cancels and this cancels. You're left with an IB divided by IA. Now you know IA is greater than IB, which means IB by IA is less than 1, which means the kinetic energy of A is less than the kinetic energy of B. I will just quickly revise it for you. I started with this approach, but then I realized in the question, moment of inertia is the key focus, not velocity and radius. So I did not take the angular momentum for a point mass. Rather, I went for the angular momentum of a rigid body having an angular velocity of omega. So this is one expression. I equated the angular momentums to be equal because it was given in the question that LA is equal to LB. Then I wrote the expression of kinetic energy for the rotational bodies, half I omega squared. I divided the two because the aim was only to compare. And then I used this expression of equality of angular momentum. I did some algebra there, brought it here and substituted and was able to compare the two. Do not forget to subscribe to my community. Do not forget to subscribe to this channel. You will see some outstanding questions which will help you immensely in your school paper. Score high and without much effort. Just watch the videos very carefully, and these will help you in building a good career. Because if you get a good college and a good rank, your career is safe. So thank you very much for your time, and wait for my next video.